Okay, ladies and gentlemen, let's get right to the point. Let's put our thinking caps on. 6.2, this entire section, this entire packet that you get is the foundation for trigonometry, and as we keep going. So we're going to look at the unit circle. We're going to start building the unit circle. And the way that we build the unit circle is through right triangles. So you're probably thinking like, oh my God, I have to take right triangles, which builds this circle. And if you look at the picture that you have right in front of you, look at that. So what happens is I can pick any point that I want on a circle. I know this right here is going to be the radius. I know the angle formed is going to be theta, which is right there. Notice that I drew this line down from here to build a right triangle. So in a circle, there are infinitely many right triangles. Think about this. What if I picked a point like right here? Well, think. There is going to be the radius. I'll be able to draw this line right here, which forms a right triangle right there. So, do you see how there are infinitely many right triangles in a circle? All right. So, with that being said, I tell you, I'm reading this sentence right here. Let theta be an angle in standard position. So, standard position, I know that means that this right here is theta. That's a terrible theta. I'm going to make it a little bit nicer than that. Okay, that is theta right there. P is a point. Any point on the terminal side of the angle except the origin. So here is a point. And r is equal to the square root of x squared plus y squared. What I want you to do, I'm going to have you cross this out. I decided I'm going to change my mind, because I think you'll make the connection a little bit better when I tell you this. The standard form of a circle is x squared plus y squared equals r squared. I'm telling you that's how you write the equation of a circle, right? Standard form. Can you make the connection? Look at that standard form of a circle, x squared plus y squared equals r squared. What does that kind of look like? How can I relate that to my right triangles that I have here? Do you see the connection between the two of them? Understand that, okay, in order to solve a right triangle, I use the Pythagorean theorem, which is a squared plus b squared equals c squared. Now I understand why this thing right here, now I understand why that's an equation of a circle. Because in a circle, I can create infinitely many right triangles. So I understand the connection between them, and now I understand that this is the formula that I'm going to use. So, think about it. With my right triangle that I have here, I know this side is x, right? Because that's the distance on the x-axis from here to here is an x value. I know that this one would be y, right? Think from here to here is a y value. And I know this would be the radius. So, as long as I understand sine, cosine, tangent, SOHCAHTOA, hopefully you're staying up and you're studying those, I know sine is opposite over hypotenuse. So in terms of a circle, sine is going to be y over r. How the heck did I get that? I looked at theta, and I said opposite over hypotenuse. Right, so hopefully you're still with me. You're going to be, it's a lot of information, so you better get used to it. Cosine now is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, and now because I know that cosecant is the inverse of the sine, I know this thing is r over y. I know secant is the inverse of the cosine, so I know that this thing is r over x. I know that cotangent is the inverse of the tangent, and therefore this is x over y. Ladies and gentlemen, this box right here, smack that puppy right in the front of your notebook. More formulas for you to remember. If you don't remember SOHCAHTOA, this is now snowballing on you because I just threw 6 more trig functions that you're going to need to know for your next pop quiz. So if you don't know SOHCAHTOA and know which ones are inverses of each other, you are way behind the stick. I mean, way behind the stick at this point. Because, watch this. Oops, I already took care of all that stuff for you. Go back to train up a little bit. Okay, so letter A. I say to you, suppose that the angle, which I call theta, is in standard position with a point -2, 3 on its terminal side. Evaluate the 6 trig functions for theta. So, first thing I'm going to do is obviously draw a picture. I drew my circle. I know standard position means that I start at the initial side, I end at the terminal side. It said that that point, -2, 3, is on the terminal side, so I know that -2, 3 is on that terminal side. So if you want to label this point here, -2, 3, great, do that. So in order to evaluate my 6 trig functions dealing with a circle, I know I have to use those formulas that I had on the first side. I know sine is y over r, cosine is x over r, tangent's y over x, etc., etc., etc. Well, in order to do that, I'm going to need to figure out what r is. How do I figure out r? Well, I'm going to use the formula for a circle. X squared plus y squared equals r squared. I know x is -2. I know y is +3, right? I got that from this point. I'm going to have to figure out what the radius of this circle is. How do I do that? Well, I'm just going to solve this from here. So I know the radius of this circle is the square root of 13. As long as I know that, I now know what x is, I now know what y is, I now know what r is for this circle. I'm ready to run through those 6 trig functions. So there's what I know. I know x is -2, y is +3, r is the square root of 13. So think, sine, y over r. Well, I'm not allowed to have square root in the denominator, so I got to rationalize that thing. Multiply top and bottom by the square root, and voila, there it is. Cosine, x over r. Tangent, y over x. Cosecant, inverse of the sine. Secant, inverse of the cosine. Cotangent, inverse of the tangent. Again, if you are not studying on a daily basis, you are falling way behind the stick. I told you, trig, as long as you know your formulas, this should be really, really easy. The second that you're getting them confused, you are going to be completely lost. So, I didn't mean to scare you. I'm sorry if I did, but one more thing before I end this video for today. It's going to be important as we keep going to know, okay, the sine of theta in the first quadrant, right, here's where I'm looking, here's where I'm looking. The sine of theta in the first quadrant, what are all of those answers going to be? Are they going to be positive or are they going to be negative? Sine in the second quadrant, positive, negative. Third quadrant, positive, negative. Fourth quadrant, positive, negative. I have to know all of that for every single one of these functions without any hesitation. I have to know whether I should get a positive or a negative answer before I even start. Notice up here, we're in the second quadrant. Look, I'm looking at this example right here. I'm in the second quadrant. Sine is positive, cosine's negative, tangent's negative, cosecant. I have to know whether they're going to be positive or negative, and you're probably saying to yourself, holy crap, how the heck am I going to remember that? Well, hopefully you have faith in me at this point to understand that I'm going to help you out as much as I possibly can. I know sine is y over r. I know cosine is x over r. I know tangent is y over x. So if I think about it in the first quadrant, which is right here, if you don't know your quadrants, 1, 2, 3, 4, right? That's the last time I'll tell you those. So in the first quadrant, all y values are positive, all x values are positive. Radius is always going to be positive, right? You can't have a negative radius. So if all y values are positive in the first quadrant, when I do y, which is positive, over r, which is positive, I know in the first quadrant that's going to be positive. Second quadrant, think here's where I'm at now. Y over r, y values are still positive, r value is always positive, so I know that this answer is positive. I'll do one more for you, and then you should probably fill out this table on your own. Third quadrant. Now the y values are all negative. The radius is positive. Negative divided by positive is negative. Fourth quadrant, negative. Cosine, that's what you should get. X over r. Tangent, y over x, that's what you should get. Obviously, if the sine is positive and negative in those quadrants, that means that the cosecant is also going to be the same thing. Secant is also going to be the same thing. Cotangent is also going to be the same thing. Right? So understand, because they're inverses, they're still going to be the same, positive or negative in those quadrants. You're probably sitting here like, holy crap, Mr. Whitehouse, how the heck am I going to remember all of that? Well, I have a great strategy for you to remember this. Here's what I remember. As long as I remember a simple trig chart. Right? Think about a simple trig chart. What I'm really focusing on, notice that I capitalized these letters here. So, a simple trig chart. It goes in the order of the quadrants. A simple trig chart. What that means is that, watch this, this is genius. A stands for all of them. Every single trig identity is positive in the first quadrant. Look at that. They're all positive in the first quadrant. S stands for the sine. The sine is the only thing that's going to be positive in the second quadrant. Everything else is going to be negative. Well, sine and obviously its inverse. So a simple, T stands for tangent. Notice the tangent is the only thing positive in the third quadrant, sorry. And then C stands for cosine. Cosine is the only thing positive in the fourth quadrant. So if you remember a simple trig chart, you should be able to remember which ones are positive and negative and in what quadrant they are in. Questions, comments, concerns, post them. Good job.